Welcome to ThinkViL educational videos. In this video, we will learn about rain-person problem and relative motion, covering their theory, key concepts, important formulas, and practice questions. First, let's understand, what is rain-person problem? The rain-person problem is an example of relative motion that explores the best way for a person to move in the rain to minimize getting wet. It analyzes whether walking or running is the better option when caught in the rain. Rain-person problem ThinkViL simulation is based on the concept of rain-person problem. Now, what is relative motion? Relative motion is the movement of an object as observed from another moving object, and it is described by relative velocity. It depends on the observer's frame of reference. For example, relative motion of cars and rain-person problem. Now, what is relative velocity? Relative velocity is the velocity of an object as observed from another moving object. It is the difference between their velocities and depends on the observer's frame of reference. If object A has a velocity of VA vector and object B has a velocity of VB vector, then the relative velocities will be velocity vector of object A with respect to object B is equal to VA vector minus VB vector, and velocity vector of object B with respect to object A is equal to VB vector minus VA vector. Let's visualize the rain-person problem in rain-person problem ThinkViL simulation. For access the simulation visit www.thinkvil.com. Now open the simulation, you will see this layout. Here, this is the observer with umbrella. Initially, the observer has no velocity. Now, the rainfall starts falling vertically downward. Here, you will observe that the observer can protect themselves from the rain without changing the umbrella's position. Now, let's give some velocity to the observer. Now, what will happen? Can the observer still protect themselves from the rain? The answer is no. Now, you will observe that the rainfall appears at an angle. To protect yourself from the rain, you should hold the umbrella at a certain angle. So, we need to determine the correct angle at which you can stay protected. In this case, the safe angle is 21 degrees. Now, if we adjust the umbrella to this angle, you can see that the observer stay protected from the rainfall. Let's understand the physics behind this. First understand, what is safe angle? The safe angle is the angle at which an observer must hold the umbrella to be protected from the rainfall. Now, we will derive the mathematical expression for the safe angle. Let's assume VO as the observer's velocity vector in x direction. Now, assume that the rain is falling with velocity vector v r at an angle phi from the vertical in the anticlockwise direction. Next, we calculate the rain's velocity vector with respect to the observer. This represents the velocity of the rainfall as observed by the moving observer. To stay protected from the rain, the observer must tilt the umbrella in the opposite direction of the resultant velocity. Now, here theta is the safe angle from the vertical which can be determined using the following formula. Let's understand this with an example. A person has a velocity of 5 meters per second, while the rain is falling with a velocity of 8 meters per second at an angle of 15 degrees from the vertical in the anticlockwise direction. What should be the safe angle at which the person should hold the umbrella to stay protected from the rainfall? Let's first visualize the question in rain-person problem ThinkViL simulation. Now, open the simulation and enter all the given inputs. Now, start the simulation. Here, you can see that without the correct umbrella angle, the observer is not protected from the rainfall. Now, check the safe angle, which is 21 degrees. Now, stop the simulation and rotate the umbrella to the safe angle. Now, the observer will be protected from the rainfall. Let's solve the question by using the safe angle formula. Here, you will get the same safe angle as obtained in the simulation. For practice more questions, explore ThinkViL questions. Thanks for watching the video. For access more educational resources, visit www.thinkvil.com. And don't forget to like, subscribe, share, and press the bell icon for more updates.